Have you ever written what you thought was the perfect prompt for GPT-4, only to see it completely fall on its face in Claude? Or maybe you got this amazing, perfectly structured response from Gemini that you just can't seem to get out of any other model? All right, let's get right into it because today we are cracking the code on model-specific prompts. This is the real secret to unlocking the full power of any AI you're working with.
You know, it's one of the most common and, frankly, most frustrating things for anyone working seriously with AI. You can spend hours refining a prompt, getting it just perfect, and then you switch models, maybe for cost or for speed, and boom, nothing. Your masterpiece prompt just spits out garbage. But listen, it's not you, and it's not a bug. It's actually a core feature of how these AI systems are built.
And the payoff for figuring this out is, well, it's huge. We're not just talking about making your life a little easier. The research is clear. When you tailor your prompts to the specific model you're using, you can see up to a 25% jump in response quality, a 30% drop in errors, and a 20% boost in how well the model actually follows your instructions. I mean, that is a massive performance gain that most people are just leaving on the table. So let's call this what it is, the cross-model headache. It's that challenge every single developer and prompt engineer runs into when they're trying to build something that needs to work with more than one AI model. You want the flexibility to switch, but the models themselves, they're demanding specificity.
And here's the absolute crucial point. This is not a mistake on your part. It is a fundamental reality of how these things are designed. Every large language model has been trained differently, on different data, with different fine-tuning techniques and different architectures. Expecting them all to react the same way to the same prompt? It's kind of like expecting two people from completely different cultures to interpret a really complex phrase in the exact same way. It's just not going to happen.
You know, the best way I've found to think about this is that AI models speak different dialects of the same language. Sure, they all understand English, but each one has its own little quirks, its own slang, its own conversational patterns, and its own preferred way of being spoken to. If you want the best results, you've got to learn to speak their specific dialect.
So, okay, why? Why do these dialects even exist? Well, it really boils down to four main things. First up, their training data is totally different. Gemini was trained with a huge focus on multimodality, while Claude was really focused on being helpful and harmless. Second, their internal architecture varies. Third is their instruction tuning. That's the process of teaching them to follow commands, and they all use different formats. And finally, their API design itself kind of tells us how we're supposed to talk to them in the first place.
All right, so that's the why. Now let's get to the fun part, the how. Let's jump into the practical playbook for the big four: GPT-4, Claude, Gemini, and Llama. We're going to break down the native language of each one so you can start getting better results, like right away.
Okay, if you only remember one thing from this entire explainer, let it be this: role tokens. These are just the specific labels that define who is speaking in a conversation. Is it the system setting the rules? Is it the human user asking a question? Or is it the AI assistant responding? Seriously, getting this wrong is the #1 cause of cross-model failure, period.
And just look at this. You can see how different they are. GPT-4 uses the system, user, and assistant roles we all kind of know. But then you hop over to Claude and it expects human and assistant. Gemini wants user and model. And then you have open source models like Llama that often use this special tagged format, wrapping instructions in tags like inst. Trying to use a user role in a prompt for Claude is a classic mistake.
Now, beyond just who's talking, the models also have their own preferred formatting styles. GPT-4, for instance, loves clear, structured instructions. It works great with Markdown, and it's fantastic at following really specific JSON schemas for its output. Claude, on the other hand, has this unique and really powerful thing for XML tags. You can literally ask it to put its reasoning inside thinking tags, and it will actually structure its whole thought process for you. It's pretty cool.
Meanwhile, Gemini's big strength is its native support for multimodal inputs and its use of system instructions to set broad context. And then there's Llama. Being open source, it relies on a very specific instruction format. You have to use those inst tags to clearly separate the user's command from everything else. If you ignore those tags with Llama, it's just a recipe for a bad time.
So let's actually see what this looks like in practice. I mean, theory's great and all, but the proof is in the output, right? We're going to look at some direct before and after examples to show you just how dramatic the difference between a generic and an optimized prompt can really be. This quote here really gets to the heart of it. You can write a generic prompt that will probably get you an okay answer from most models, but okay isn't what we're aiming for.
We're aiming for optimal, and to get there, you have to leverage the unique strengths that each model was specifically trained to respond to.
So let's look at this. On the left, a generic request. Give me info about Python in JSON format. The result? It's inconsistent. It's unreliable. You can't really build an app on top of that. But now look at the right. Using a GPT-4 optimized prompt that includes an explicit JSON schema, you get perfect, predictable, and parsable output every single time. The specificity just wins, hands down.
Here's another fantastic example, this time for a complex reasoning task. The generic solve this step-by-step prompt, it works, but the solution is just a big block of text. Now look at the optimized version for Claude. By using those XML tags like thinking and analysis, we're getting Claude to first lay out its thought process clearly and separately before giving the final answer. This makes its reasoning so much more reliable.
Okay, so you've seen the why and the what. Let's wrap this all up with the practical takeaways you can start using right now to avoid these common pitfalls and build a really solid workflow for creating high-performance, model-specific prompts.
Here are the 3 biggest mistakes to avoid. First, please don't just copy-paste your GPT-4 prompts with user and system roles straight into Claude. It wants human and assistant. Second, don't ignore a model's superpower. If you're using Claude, use the XML. If it's Llama, use the instruction tags. And third, and this is a big one, never assume a prompt will work the same way across different models. Always, always test.
So what's a better way to do it? It's a simple 4-step workflow. 1. Always identify which model you're targeting. 2. Do a quick search of their documentation for the right role tokens and formats. 3. Create a specific prompt template just for that model. And 4. Test and optimize. I promise, this little bit of time up front will save you hours of headaches down the line.
And let's not forget why we're doing all this. It all comes back to performance. By speaking the model's native dialect, you are directly tapping into a potential 25% increase in the quality of its responses. That is a massive competitive advantage.
And that brings us to the final question you really have to ask yourself. After seeing how these models are different and the clear benefits of speaking their language, are you okay with leaving a quarter of your model's performance on the table by using those generic, one-size-fits-all prompts? The tools are all here. Now it's time to put them to work.